Hi friends, uh, now let us see the final point in the analysis of CurveTracing, and that is the region of accents. So on the two-dimensional plane, suppose y equal to f of x is the curve that you are tracing. Okay, on this plane you find out the area where the curve does not exist. How to get that? So what you do is you find out the values of x, for which y is complex, okay, or vice versa, right? That means find out the values of y for which x is complex. Okay, in that case, in that particular for values of y and x, the curve not exist. I'll give you an example. Suppose you take y square is equal to 4x, right? Y square equal to 4x. Now see that if I take x to be less than 0, what I will have? If x is less than 0, this quantity is negative, and then y is complex, because y square will be negative, so y will be under root of negative sign, and that you know that it is a complex number. So for x less than 0, this curve not exist. Okay, now if you actually plot this, now x less than 0 means what? The entire second and third quadrant. See, entire second and third quadrant, the x part is negative. Okay, if you plot this, this is a parabola, we know that it's y square equal to 4x, so this is kind of parabola. So see, the parabola exists only in this part and not in this part. Why? Because when x is less than 0, the curve is constant, right? Y is complex. Okay, so for given equation, it is very necessary that we should determine the region of accents of the curve. Okay, and that can be calculated by looking at the values of x for which y is complex. Similarly, or you can say, or vice versa, looking for values of y for which x is complex. Okay, so um, we will get the region of accents, and accordingly we can see where the curve exists and we can draw in that part. I hope you have got this concept. Okay, we'll see the illustration in the next video. Thank you.